Okay, so welcome back. We are now moving on to section 7.3. And of course, in this section, we're going to be learning about what are called the quantifier negation rules. Now, the first thing I should tell you is that when I'm talking to you about the quantifier negation rules, or the QN rules, I may occasionally slip into calling them the change of quantifier rules. And that's because our text used to refer to these rules as the change of quantifier rules, but now in this edition, they're calling them the quantifier negation rules. I'll talk to you in a little bit about why I actually prefer the name change of quantifier rules, but for the time being, we'll be calling them the quantifier negation rules in accordance with the text. So before we get into any of that, I'm going to have us look at this statement here. And of course, what this is saying is for all x, be x, or something along those lines, right? Take anything you want, that thing is a b. And my question is, could we think of anything to plug in for b here that would make this a true statement, right? And I ask my face-to-face classes this question, and usually there's a long pause here because it's certainly not easy to come up with anything that would make this a true statement, right? Certainly if we plugged in, for example, B standing for being a banana, that would definitely not be true, because then that statement would be saying that everything in the universe is a banana. Clearly not the case. So, in fact, one of the reasons that I think people are a little bit uneasy when I ask them this question is because we're starting to dip our little toe into the deeper waters of philosophy here, finally, after this entire course. And that's because, if we think about questions like this, is there anything that, any characteristic that applies to all things in the universe? For many people, the answer is no. In other words, there's nothing that can be plugged in for B here to make this a true statement. But what I want to tell you is that actually there are, in fact, several hundred millions of people on the planet who would say that, in fact, there is something that could be plugged in to that in order to make that a true statement, and that would be that B would stand for Brahman. And so what is Brahman? Well, you can take Introduction to World Religions, you can take Introduction to Philosophy, Philosophy of Religion to find out more about Brahman, that concept. But basically, it's a concept from Hinduism that suggests everything in the universe, you and I, the pen, the carpet, everything, is a manifestation of Brahman. So we're not going to get any more deeper into that, but they would say you could plug that B in with that concept. Now, let's just for a second imagine that you believe that. In other words, you are one of these types of Hindus that you believe that every single thing in the universe is a manifestation of Brahman. Now, if you believed that, right, you would also believe, wouldn't you, that it's not true that there exists something that isn't Brahman, right? If you believed every single thing in the universe was Brahman, then you would believe it's not true that there exists something which is not Brahman. So in other words, and why I use these two colons here, the statement on the left here means the same thing as the statement on the right. They're logically equivalent. And just as we saw in Chapter 6 with the replacement rules, we're going to use 4 dots here, or 2 colons, to indicate that these are equivalent statements and that the statement on the left can be replaced with the statement on the right, and vice versa. Now, this is the first of, again, what we're calling the quantifier negation rules, QN rules. Let me write that down a little lower so we can continue to see it here. Okay, the QN rules. There are 4 versions of the QN rules, and so let's go back to this. Let's generate all of them here with some discussion. Let's say you were among the people who believed it's not the case that everything was Brahman. I'm actually going to squeeze that over just a little bit to make sure it's fitting on your screen. All right? So in other words, you might believe that Brahman exists somewhere, but it's not true that everything is Brahman, right? Brahman might be over there, but you might not be Brahman. And in fact, some Hindus would actually believe this instead of this statement here at the top. Now, if you believe it's not true that everything is Brahman, again, that's like saying, isn't it, that there exists something which is not Brahman. Right? If you believe that not everything is, you're essentially saying there exists something which is not Brahman. And so once again, the statement on the left means the same thing as the statement on the right. Okay. So I'm just trying to give you some motivation as to where these rules come from. But to finish off the list, the other two versions of the quantifier negation rules, let's bring things down to earth a little bit more. Maybe not all the way down to earth, but how about down to Mars? Okay. So let's talk about Martians for a second. So I don't know where you stand on the whole notion of whether or not there are Martians, but one possibility, right, is that you think that Martians exist, right? There exists something that is a Martian. You might be in that camp. On the other hand, you might reject that notion, right? You think it's not true that there exists something that's a Martian, right? So you might think that that's not the case. Martians don't exist, in other words. Okay. Well, let's take this second version here, the second statement. It's not true that there exist Martians. If you believe that Martians don't exist, right, another way to say that then would be to say that take anything you want, it's not going to be a Martian. Right? If it's not true that Martians exist, then you're saying, take anything you want, it's not going to be a Martian. Okay. On the other hand, if you believe that Martians exist, would you accept this, right? If you believe that Martians exist, would you agree with the statement that take anything you want, it's not going to be a Martian? Right? You wouldn't accept that. And so in logic, of course, how we express disagreement or that we wouldn't accept this statement is that we put a tilde in front of it, right? So in other words, Martians exist means the same thing as it's not true that you could take anything you want and it won't be a Martian. To say that Martians exist suggests that eventually when you keep taking things, when you keep picking them up, you would come to a Martian. I would suggest dropping it right away if I were you. But anyway, so what we have here are the quantifier negation rules. And what we're saying is that all the statements on the left mean the same thing as all the statements on the right, and that they're basically replaceable with one another. Now, of course, if you look at our text and the way that Hurley has expressed these, you'll notice that he doesn't use B and M, of course, and so he uses this fancy script F that, again, I cannot possibly hope to recreate, but I can at least replace these B's and M's with an F to more closely mirror the textbook. Okay? Let me do that here real quick. All right, so there you have the four versions of the quantifier negation rules. And so again, what we're talking about here is the statements on the left can be replaced by the statements on the right. Now at the beginning of this particular video, right, I talked to you about how they used to be called the change of quantifier rules. And I hope you can kind of pick up on why that might be, right? Because as you'll notice here, anytime you go from left to right, or vice versa, the quantifier changes. It goes from a universal quantifier to an existential, a universal to an existential to a universal, and so on, right? So the quantifier is always changing, and that rule, therefore, is, makes a certain sense to call them the change of quantifier rules. But again, for whatever reason, Hurley, the author of the text, is now calling them the quantifier negation rules. And so what I do want you to know, though, is that if people sometimes misapply the quantifier negation rules, it's because they forget to change the quantifier when they apply that. So be sure that you're doing that. Be sure you're always changing the quantifier anytime you're applying the quantifier negation rules. Now, I know that it's getting close to the end of the quarter, and here all of a sudden, right, you're getting thrown a bunch of statements here with a lot of squiggly lines and a lot of strange symbols, and it might seem a bit intimidating to try and memorize this. And of course, this won't be on any quiz, so you don't have to memorize this. Definitely you want to put these on your note sheet for the last exam. But I want to just share with you how, even though this looks perhaps somewhat intimidating, if you can just remember one thing, you can basically get almost everything that's going on here, okay? And that is this. All you need to remember is that the way that the quantifier negation rules work is that if you have a single tilde here, you can flip it to the other side of the quantifier, and it will change the quantifier. Now, that certainly accommodates this version of the rule, right? Have a single tilde, move it to the other side, and it changes the quantifier. And that works. That description works for this one here at the bottom as well. So even though I want to say that that actually works pretty well for these two versions of the rule as well. So in other words, let's say you had this statement here, and for whatever reason you wanted to change the quantifier, okay? And you thought, now how does that quantifier negation rule work? Well, if all you could remember is, oh yeah, all I need to do is move the tilde to the other side of the quantifier and it will change the quantifier, you'll be just fine. Because you can take that tilde, for example, and you move it to the other side of the quantifier and it changes the quantifier. That's the quantifier negation rules on line 1 here. And of course now you have these two tildes right next to each other. And we know that double negation will take care of those for us, okay? So even if you couldn't remember, of course, the easier way to do this would be just to go straight from, where is it here, this one to this one, right? You could do that in one step, go right from 1 to 3 here with quantifier negation rules. But if you couldn't remember that or whatever, if you could just remember, move a tilde over and it'll change the quantifier, you'll still get to the same place that you want to get to, okay? I also want to note here that double negation, of course, does apply to line 2 because the two tildes are right next to each other. But, for example, line 1 here is not a good candidate for double negation. In other words, you can't go from 1 here to simply, for all x, ax, just dropping the two tildes there, because double negation does not work for tildes that are separate from one another, right? Double negation only works when the tildes are immediately next to each other. So, just want to make sure you understand that. And let's see, I think that basically covers what I wanted to talk to you about with regard to the quantifier negation rules, except to say that these are replacement rules, just like we saw in Chapter 6. And so the quantifier negation rules work on parts of lines. In other words, if I had this as my line 1, I could simply use the quantifier negation rule on that first part of this conjunct, right, turning it into this, and then I carry down the rest of it. So the quantifier negation rules, like all replacement rules, do work on parts of lines, and so that'll be a useful thing to make to note when we start to work on some proofs using the quantifier negation rules here in the next video.